the hottest years in history. Imagine waking up one morning and discovering that the planet has basically turned the thermostat to maximum. Your bed is hot. Your car is hot. The sidewalk is hot. Even the air feels like it has been left inside a microwave. Now imagine that this is not one bad afternoon. It is an entire year. And the scary part is this. Some of the hottest years ever measured are not ancient history. They are happening right now. So grab some water. Because we are going through the hottest years in recorded history. And yes, Earth has always had hot days. But these numbers are getting ridiculous. Number 1. 2024. If Earth had a customer service department, this would have been the year to call. 2024 became the hottest year in the modern instrumental record. Global average temperature reached roughly 1.6 degrees Celsius above the estimated pre-industrial average used by major climate datasets. That number may sound small. It is not. We are talking about the average temperature of the entire planet. Land, ocean, mountains, deserts, cities, everything. A few extra degrees in your bedroom is annoying. A similar change in the global average is enormous. 2024 was packed with heat records. Several months were extraordinarily hot. June 2024 was the 12th month in a row that set a record for global monthly temperature in the Copernicus dataset. 12 months. An entire year of climate records falling like dominoes. Ocean temperatures were also exceptionally high. That matters because oceans absorb huge amounts of heat. They also help power storms. Meanwhile, Antarctica experienced unusual heat in some periods. Parts of Europe, Asia, Africa, and the Americas suffered dangerous heat waves. In many places, temperatures passed levels that can be deadly without cooling, water, and shelter. And then there was one important detail. 2024 was not just a random hot year. It came after an already very warm period. Which brings us to number 2. 2023. For a while, 2023 looked like it was going to keep the record for itself. It became the warmest year ever recorded at the time. Global temperatures were pushed higher by long-term human-caused warming. Then came El Niño. El Niño is a natural climate pattern. It moves heat from the tropical Pacific Ocean into the atmosphere. Basically, the Pacific decided to contribute. And it contributed a lot. 2023 delivered extraordinary heat across huge parts of the world. But the heat was not evenly spread. Some regions were much hotter than the global average. Southern Europe suffered brutal summer heat. China experienced major heat waves. The Middle East faced dangerous temperatures. North America also endured intense heat. And the ocean was doing something strange. Sea surface temperatures reached record levels. Scientists were watching the numbers and asking an uncomfortable question. How hot can this get? The answer arrived in 2024. Number 3. 2016. Before 2023 and 2024 took over the headlines, 2016 held the record. It was another year strongly influenced by El Niño. The beginning of 2016 was especially remarkable. Global temperatures surged. January and February were extraordinarily warm. Some monthly records were broken by surprisingly large margins. This was not just a hot summer. The entire climate system was running hot. The Arctic was particularly important. Sea ice was unusually low at various points. Warm conditions in the Arctic can have effects far beyond the frozen north. Snow and ice reflect sunlight. Dark ocean water absorbs more sunlight. So when ice disappears, the planet can absorb more energy. It is a nasty little feedback loop. Heat melts ice. Less ice means more sunlight is absorbed. More absorbed energy means more warming. And the cycle continues. 2016 also showed something important. Natural climate patterns can temporarily push global temperatures higher. But they are riding on top of a long-term warming trend. Number 4. 2020. This year was almost tied with 2016 in several major datasets. And that is remarkable for another reason. There was no giant El Niño event pushing temperatures upward. Instead, 2020 was simply extremely warm. It was one of the hottest years ever measured. The Arctic again attracted attention. Siberia experienced extraordinary heat. A temperature of 38 degrees Celsius was recorded in the Siberian town of Verkhansk in June 2020. That reading was accepted by the World Meteorological Organization as the highest temperature recorded north of the Arctic Circle. Think about that. Siberia, the place people imagine when someone wants to describe freezing weather. And there it was, 38 degrees. The weather basically forgot the assignment.
So,
Number 5. 2019. Another extremely hot year. Another climate record. 2019 ranked among the warmest years ever recorded. Heat waves affected many countries. Europe was hit particularly hard. France recorded 46 degrees Celsius during a June 2019 heat wave. That was a national record at the time. Spain also experienced extreme temperatures. Germany broke its national temperature record in June. The important thing is not just that one thermometer got very high. Heat waves are dangerous because they can cover huge areas. They can last for days. They can stress electricity systems. They can damage crops. They can make outdoor work dangerous. And nights matter too. If nights stay hot, people have less time to recover from daytime heat. Your body basically wants to cool down. The weather says, absolutely not. Number 6. 2017. This year was extremely warm despite the absence of a major El Niño event. That made it especially important to climate scientists. It showed that record-level warmth was becoming normal enough to appear without a major natural boost. Large parts of the world experienced dangerous heat. The Middle East saw some astonishing temperatures. Kuwait recorded 53.7 degrees Celsius at Mitraba in 2016, a measurement that was later adjusted slightly after review. That number remains a reminder of how extreme regional heat can become. The human body does not negotiate well with temperatures like that, especially when humidity is high. Sweating is one of the body's best cooling systems, but sweating becomes less effective when the surrounding air is already loaded with moisture. That is where wet bulb temperature becomes important. It measures heat while accounting for humidity. At sufficiently high wet bulb temperatures, even a healthy person can struggle to cool down. That is when heat stops being merely uncomfortable. It becomes a survival problem. Number 7. 2015. Another member of the modern record-breaking group. 2015 was the first year in which global average temperature was clearly more than 1 degree Celsius above the late 19th century baseline used by many climate assessments. That milestone mattered. 1 degree may not sound dramatic. But remember, this is the global average. It includes the oceans. It includes cold regions. It includes nighttime temperatures. It includes places where warming is smaller. Some land areas warm much faster. The Arctic is a prime example. And the difference between 1 degree globally and 1 degree in your house is not comparable. Climate is about enormous amounts of energy moving through a gigantic system. Add energy to that system. The system changes. Number 8. 2018. It was another very warm year. And it brought brutal heat waves. Japan experienced a deadly heat wave during the summer. Temperatures climbed above 40 degrees Celsius in several locations. The heat was so severe that authorities urged people to treat extreme temperatures as a major disaster risk. Europe also experienced a very hot summer. Northern countries saw unusual heat. Wildfires became a major problem in several regions. And then there is agriculture. Crops have temperature limits. Too much heat during flowering or grain filling can reduce yields. Livestock also suffer. Water demand increases. So a heat wave can become much bigger than a weather story. It can become a food story, a water story, an economic story, and sometimes a public health crisis. Number 9. 2010. This year stands out because of several devastating regional heat events. Russia experienced an extraordinary heat wave in the summer of 2010. Temperatures soared. Wildfires spread. Moscow was surrounded by smoke. Agricultural production was damaged. Thousands of excess deaths were linked to the heat and related conditions, although estimates vary depending on the method used. The heat was persistent. That is the key word. Persistent. Extreme heat becomes much more dangerous when it refuses to leave. Your body can survive a hot afternoon, but several days of intense heat can push vulnerable people into serious danger. The 2010 Russian heat wave became one of the clearest examples of how climate extremes can combine. Heat, fire, smoke, crop losses, health impacts, all arriving at the same time. Number 10. 2003. Now we go back to one of Europe's most infamous heat waves. The summer of 2003. Europe was hit by extraordinary heat. France was especially affected. Temperatures remained extremely high. Hospitals became overwhelmed. Morgues ran out of space. Thousands of people died across Europe. Estimates vary, but research has placed the number of excess deaths across Europe at more than 70,000. France alone suffered tens of thousands of excess deaths. Older people were particularly vulnerable. Many lived alone. Some homes had poor ventilation. Air conditioning was far less common than in some hotter countries. And nighttime temperatures stayed high. That meant the body could not properly recover. The 2003 heat wave changed how Europe thought about extreme heat. It showed that heat could kill on a massive scale. Not with explosions. Not with earthquakes. Not with dramatic scenes from a disaster movie. Just air. Very hot air. And that may be one of the strangest things about heat. It can look completely ordinary. The sky is blue. The streets are quiet. Nothing appears to be happening. But inside the human body, the emergency has already started. There is another important part of this story. Some of the hottest years in recorded history are clustered together. That is not what we would expect from random weather alone. The long-term trend is clear. Earth is warming. Human activities are the main reason. Burning coal, oil, and gas releases greenhouse gases. These gases trap additional heat in the climate system. Deforestation also contributes. The planet is not simply getting hotter because the sun suddenly woke up angry. Solar changes happen. Volcanic eruptions happen. Ocean cycles happen. But they do not explain the modern long-term warming trend. The greenhouse effect is real, and humans have strengthened it. There is also a strange twist. The hottest year does not necessarily mean every place is hot. Global averages can hide enormous regional differences. While one country suffers a heat wave, another may have unusually cool weather. That does not cancel global warming. Weather is local. Climate is the long-term pattern. Think of it like rolling dice. One unusual roll does not prove the dice are loaded. But if the average keeps shifting in the same direction over hundreds of rolls, you start asking questions. And the climate dice are changing. There is also a difference between weather records and climate records. A single city can have its hottest day ever. But that does not mean the planet has had its hottest year. A year is an average across a massive area. That makes global temperature records surprisingly difficult to achieve. You need warmth across many regions. Land, ocean, north, south, tropics, and especially the oceans. The oceans are doing most of the heavy lifting when it comes to absorbing excess heat. That is one reason ocean temperatures matter so much. They also influence sea level. Warm water expands. Melting glaciers and ice sheets add more water. So rising temperatures can eventually affect coastlines. The hottest years are therefore not just about people sweating through their shirts. They are connected to a much bigger system. Ice, oceans, rain, storms, agriculture, health, wildfires, and ecosystems. Animals have limits too. Some species can move. Others cannot. Plants cannot simply pack a suitcase and relocate because the weather has become unreasonable. Coral reefs are another example. Marine heat waves can cause coral bleaching. If severe heat continues, coral ecosystems can suffer major damage. And here is the uncomfortable part. The hottest years are not necessarily the final chapter. If greenhouse gas emissions remain high, future decades are expected to contain even more extreme heat. That does not mean every year will automatically break the previous record. Climate records can bounce around. El Niño can push temperatures higher. La Niña can temporarily cool things down. Volcanic eruptions can also affect global temperatures. But the baseline keeps moving. Higher and higher. That means a future El Niño could push global temperatures into territory that once seemed almost impossible. So what should we take from all this? First, Earth has always experienced heat waves. Extreme weather is not a brand new invention. Second, the modern warming trend is different because it is global and long-lasting. Third, recent years are dominating the temperature record. And fourth, the hottest year is not the most important number. The trend is, one record can be broken. Another record can be broken. But when record after record keeps appearing, that is when the story becomes much bigger. From the brutal European summer of 2003, to the Russian heat wave of 2010, to the record warmth of 2015, 2016, 2019, 2020, 2023, and finally 2024. The planet has been sending a very clear message. And unfortunately, it does not come with an unsubscribe button. The good news is that the future is not completely written. Human choices still matter. Cleaner energy can reduce greenhouse gas emissions. Better cities can reduce dangerous heat. Trees can provide shade. Buildings can be designed to stay cooler. Early warning systems can save lives. Hospitals can prepare. Workers can be protected. And countries can adapt to the heat that is already coming. Because the goal is not to make Earth cold. Earth is supposed to be warm. We just do not want to turn the whole planet into the world's largest sauna. And there is one more reason these records matter. Temperature is only one piece of the puzzle. Heat changes evaporation. It changes rainfall. It dries soil. Dry soil can make fires spread faster. Hotter air can also hold more water vapor. That can help produce heavier rainfall when storms develop. So warming does not simply mean every place becomes dry. Instead, the water cycle can become more extreme. Some places face drought. Others face intense rainfall. And some regions can experience both. This is why climate scientists watch more than thermometers. They watch oceans, ice sheets, glaciers, rainfall, soil moisture, wildfires, and the health of ecosystems. The climate system is connected. Push one part hard enough, other parts begin responding too. So the next time someone says, "It is just a hot summer," remember, one hot afternoon is weather. A record-breaking year is climate. And when the hottest years in recorded history start appearing one after another, maybe it is time to stop blaming the thermometer. Because the thermometer is just telling us what it sees.